In this circuit, R2 is in parallel with R3 and R1 is in series with the rest of the circuit. This is our second series in parallel type of circuit, and I'm using the VERP table to calculate the current and the voltage on each resistor. Let me start by combining R2 with R3 because they are in parallel and redraw this circuit. So here is R1 remains the same, but R2 and R3 now is combined. So this is my result, R2, 3. And the calculation will be 10 ohms parallel. So I'm using this symbol here, 10 ohms parallel with 5 ohms. So when you plug in your calculator, the result is 3.33 ohms. So here is how you do. So you type on your calculator 10 inverse plus 5 inverse, and the result you inverse one more time. So that's how you get 3.33. To calculate the equivalent resistance or the total resistance of this circuit, now we need to add, because now both are in series, the value of R1 with the value of the combination between R2 and R3 in parallel, like this. Now we have 15 ohms plus 3.33 ohms, and the final result is 18.3 ohms. Now let's add this value on our table, which is 18.3 ohms. Now that we have the total resistance and the total voltage, we can calculate the total current, which is 0.33 amps. Now this total current, 0.33, is the same current that is flowing through R1. So the current on R1 is 0.33 amps. Now we can use the Ohm's law to calculate the voltage on R1, which is 4.95, using this formula right here. So current times resistance. Okay, so now we have the voltage here, and the total voltage is 6. So we know that 6 is equal to 4.95 plus the voltage on both resistors in parallel, which is 1.05. So 1.05 volts is applied on R2 and on R3 because they are in parallel. Now I can use Ohm's law again and calculate the current on each resistor. So right here, V over R and V over R. Finally, to calculate the power, we just multiply the current times voltage for each resistor. So I have 1.63, 0.11, and 0.22. When I add them up, is 1.98 watts.